We begin with the concepts for application of congruent triangles today. So we will learn about how do we apply congruency in isosceles triangles. There are certain important properties of isosceles triangles that we are going to prove as theorems today. First one is angles that are opposite the equal sides in the triangle are equal. The second property is if the sides are opposite the equal angles, then they become equal. We are going to do a couple of numericals based on these two properties that we're going to do. And then another application for these properties, we will solve an unknown. Now, please remember a linear equation, a quadratic equation, or any kind of an equation which has a variable is known as a format for solving an unknown. So let us begin with just a recall of what is an isosceles triangle. So any triangle with two sides equal is known as isosceles triangle. So in this particular example, AB is equal to AC. Therefore, it is known as isosceles triangle. First property that we will cover is angles opposite equal sides. Implies what? That if in a triangle two sides are equal, then the angle opposite AB, the angle opposite AB will be the alphabet which is not included in AB, means C, just opposite to that. And so angle opposite AB, that is angle C, is equal to angle opposite AC, which is angle B. So angle B is opposite AC. We do a construction here. We make a we make a bisector of angle A. So AD is bisecting angle A. So when AD bisect angle A, angle BAD becomes equal to angle CAD. So we have in this triangle, this angle is equal to this angle because there is an angle bisector construction. This side is equal to this side given to us. AD is common. So we have SAS, SAS congruency rule applying in these two triangles. The triangles become congruent, and when the triangles become congruent, we can say angle B, that is the first alphabet here, is equal to angle C, which is the first alphabet of the second triangle. So angle B and angle C are the corresponding parts of the two congruent triangles that we have just proved, which become equal. So we have proved that the angles opposite equal sides are equal to one another. So this is the theorem that we have just proved. Let's move to the second theorem, which is just the converse of this theorem. In this theorem, it was given an isosceles triangle, but in the converse theorem, it doesn't tell us that it is an isosceles triangle. This is any triangle in which angle B is equal to angle C. And we need to prove that this is an isosceles triangle, implies we have to prove that AB is equal to AC. So green angle is equal to green angle. We do exactly the same construction that we did in the previous theorem. That means AD is the angle bisector. Now, orange angle is equal to orange angle because AD is an angle bisector. So we have angle, angle, side. AD is a common side for both the triangles. Angle, angle, side. So due to AAS congruency rule, these two triangles again become congruent to each other. When they become congruent, the first two alphabets here, that is AB, the first two alphabets of the second triangle, that is CA, are corresponding parts of of the corresponding parts of the congruent triangles. So AB and AC are the corresponding parts of the two congruent triangles. Hence, they become equal to each other. Hence, proved. So we have proved that when the angles were given equal to one another, the side opposite angle C, which is AB, is equal to the side opposite angle B, which is AC. Now that we have recalled these two properties that you had covered in the previous years as well, and you know how to prove them, let us move on certain numericals based on these. Numericals are the geometrical applications where we deal with numerical values of the angle measurements. So the question says that show that the angles of an equilateral triangle are 60° each. Now, please understand here, this is something that we have known for years and we have been using it. But now we are going to prove this officially. Now, it just says it's an equilateral triangle. So we use the definition of equilateral triangle. The definition of equilateral triangle is not that the angles are 60° each, but the definition of equilateral triangle is that the sides are equal to each other. So the word equi means equal, lateral means sides, so all equal sides. Now, we need to prove that the angles are equal to 60° each, all the three angles. First, we take the comparison of just the two sides, AB equal to AC, given to us. Now, AB is the side, so the angle opposite AB will be angle C. When AC is the side, angle opposite AC will be angle B. So we are applying the theorem that we have proved, that is, angles opposite to equal sides are equal. This becomes equation number 1. Now we take the second comparison, which is AC equal to BC. AC equal to BC. So if AC is the side, then angle opposite AC will be the missing alphabet from here, that is B. Please notice here also the angle opposite AC will be angle B. And the angle opposite BC, that is this side, will be angle A. This is how we locate the opposite angle. So angle B is equal to angle A, which is the second equation. Now please look at equation 1 and equation 2. This angle is equal to this angle, and so in the first equation we have angle C equal to angle B, and in the second equation we have angle A equal to angle B. So from equation 1 and 2 we gather that angle A and angle C both are equal to angle B. So if both of them are equal to angle B, it implies that all are equal to each other. So we have proved this much, that angle A is equal to angle B is equal to angle C. This much. Now we need to prove that this is equal to, all of them are equal to 60° each. So we are going to add further here that we know that the sum of the angles of a triangle is equal to 360°. So if each of them is equal to one another, let us say they are x each. Angle A is equal to x, angle B is equal to x, angle C is equal to x. So x plus x plus x, that is 3x, will amount to 180. So if 3x is equal to 180, x becomes 60°. So this is the first numerical. So now first we prove that angle A is equal to B is equal to angle C. After that we apply angle sum property and we prove that x is equal to 60°. Let's move to another numerical. It says that this is a triangle which is right angled at A. So it's a right triangle. Second information given about this figure is, it is very, very important to first comprehend the given diagram. So this angle is 90 and these two sides are equal to one another. Implies There are two special properties in this triangle. It is a right triangle and it is an isosceles triangle. So putting it together, this becomes an isosceles right triangle. So let us first only use the isosceles property. The isosceles property is that if AB is equal to AC, then angle opposite AB, which is angle C, is equal to angle opposite AC, which is angle B. So opposite to B is angle C, opposite to AC is angle B. They become equal to each other because of this property. So we have utilized the isosceles property. Now we will utilize the right angle. We know that the sum of the three angles in the given triangle, any given triangle, whether it is isosceles, right, scalene, anything, is equal to 180 degree. It is known as angle sum property of the triangle. However, in this case, angle A is given as 90 degree. So we can substitute that value here. So 90 plus angle B plus angle C is equal to 180. 90 can go that side, get subtracted from 180. So it becomes 180 minus 90, 90. We are only left with angle B plus angle C on the left hand side. Now look at equation 1. It says angle B is equal to angle C. Equation 2 says that the sum of these two angles is 90. Now please observe, if the sum is 90 here, it could be 30, 60, it could be 40, 50, it could be 10, 80. So 10 plus 80 is 90, 30 plus 60 is 90, 40 plus 50 is 90, even 1 plus 89 is 90. However, we know that the angles are equal because of equation 1. So the only possibility left now is that angle B and C both are 45 each, because 45 plus 45 is equal to 90, satisfying equation 2. B is equal to C equal to 45 satisfies equation 1 as well. After having solved the numericals, let us get to even higher level application, which is solving an unknown using the properties of the isosceles triangle. Let's look at this diagram. The question says find the value of angle BCD. This is B, C, D, A. And there are certain markings already done in the figure. So the first thing given to us is that AB is equal to AC. Now when AB is equal to AC, angle ABC is equal to angle ACB. So angle ABC, which is this angle, is equal to angle ACB, which is this angle. Now please notice here, the angle opposite AB is angle C, that is ACB. Angle opposite AC is this angle, that is ABC. And we are assuming that both the angles are x each. And the property is angles opposite equal sides in which triangle? It is important to mention the name of the triangle when there are more than one triangle given embedded in the given figure. So I simply writing angles opposite to equal sides may confuse. So we must add which triangle are we applying this property for. After that, in this figure, it is also given to us that AD is an extension of AB. That means BA has been produced to D such that BA is equal to AD. So this is given to us. However, when we look at statement number 1 and statement number 3, AC and AD both are equal to AB. Therefore, we have AC equal to AD from statement 1 and 3. Now let's look at the second triangle here. If AC is equal to AD, it implies that angle opposite AC, which is, so we have these angles equal to one another implies angle ADC, which is equal to AC, the side AC, is equal to angle ACD, which is which is opposite to side AD. However, this equation is different from this equation. Statement 2 is entirely different from statement 5. These two angles are equal to one another. We are labeling them as X. These two angles are equal to one another. We are labeling them as Y. But all four of them are not equal to each other. Reason, because these two angles are applied for this triangle ABC, and these two angles have been applied for triangle ACD. So that is why we have labeled them with different variables. Now we apply the angle sum property in triangle DBC. Please notice there are three triangles in this figure. Triangle ABC, in which we have applied the isosceles property. Triangle ACD, in which we have again applied the isosceles property. And now in triangle BDC, we are going to apply the angle sum property. This is known as ASP, that means angle sum property. So angle sum property says that angle DBC, which is angle DBC, equal to X here. So DBC is X plus angle BDC. So BDC, which is equal to Y. So BDC is equal to Y plus triangle BCD. So please notice here angle BCD. So BCD is made up of X plus Y. So that is why it is written here that angle BCD is equal to X plus Y. So according to angle sum property, the sum of the three angles is equal to 180 degree, where DBC is X, BDC is Y, and BCD is X plus Y. Putting the like terms together and using factorization, we have X plus X, that is 2X, Y plus Y, that is 2Y. Doing the factorization, we get twice X plus Y is equal to 180. Dividing both the sides by 2, 2 goes away from here. 2 divided by 2 is 1. 180 divided by 2 is 90. Hence, we have X plus Y is equal to 90. Now, let us get back to this figure and check what is X plus Y. I can say that X plus Y is this, or I can say X plus Y is this. But because we had to find the value of angle BCD, we remember we were solving an unknown. So the unknown is BCD here, angle BCD. Therefore, the sum of X plus Y, we do not take this sum or maybe this sum X plus Y, or maybe this sum X plus Y, but we take this particular sum, that is X plus Y. However, every combination of X plus Y will be 90 here. But we are going to take this combination because it is adjacent angle. It is not overlapping. X is separate, Y is separate. They have a common arm. And together they are making angle BCD. Therefore, angle BCD is equal to 90 degree. So we have solved an unknown using two properties, the isosceles property and the angle sum property. So the concepts that we have covered are, we've understood, recalled what is an isosceles triangle. We have stated and proved the angle opposite to equal sides are equal in an isosceles triangle theorem. We have also proved another theorem which is the converse of this one, that is sides opposite equal angles in any given triangle, not an isosceles triangle, will be equal. That means the triangle will become isosceles. We solved a couple of numericals based on properties from these two and the angle sum property of the triangle. We solved an unknown, how to find an unknown value, again using these properties. Thank you.